Now let us derive the condition for the possibility of common roots between two quadratic equations. So if we denote the two quadratic equations as shown here, it is a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. Now here we consider the first case, that is let's say both of the roots are common. Now since quadratic equation has only two roots and if both of them are common, then it just means that both the equations are not really different but they are one and the same. So that means it is clear that the ratio of the coefficients, that is a1 upon a2, must be equal to ratio of the coefficients b1 upon b2, and that must be equal to the ratio of constant terms, that is c1 upon c2. So that's a simple condition which we can conclude if both of the roots are common. Now let's go ahead and see the second case where we may have only one root common between the two equations. So the other roots of those two equations are not the same. So now here what do we do is, if let's say that particular root we denote by alpha, right? So we can substitute this alpha in both of the equations and rewrite the equations as a1 alpha square plus b1 alpha plus c1 equal to 0 and a2 alpha square plus b2 alpha plus c2 equal to 0. So therefore by solving these two equations by cross multiplication, we can write down alpha square divided by the particular cross product, as we know. So that is equal to b1 c2 minus b2 c1. This is equal to minus of alpha upon the similar cross product, that is a1 and c2, a1 c2 minus a2 and c1, a2 and c1, which is further equal to, considering the constant term now, it is 1 upon a1 b2 minus a2 b1, the remaining cross product. So if we change the middle expression with the sign, that is if we want to remove the minus sign in the numerator, we will have to change the sign in the denominator also, so that will become a2 c1 minus a1 c2. So therefore now let us write the equations or compare the alpha and alpha square terms, and therefore now we can write alpha square to be equal to, if we compare this with this, on equating we can write down alpha square to be equal to b1 c2 minus b2 c1 whole upon a1 b2 minus a2 b1. Similarly, if we equate these two particular equations, so we will have alpha equal to a2 c1 minus a1 c2 whole divided by a1 b2 minus a2 b1. And since we can put the value of alpha in this particular equation, we have a2 c1 minus a1 c2 upon a1 b2 minus a2 b1, the whole square, equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. So On simplifying further, we will get a particular result, that is nothing but C1A2 minus C2A1 the whole square is equal to B1C2 minus B2C1 in the first bracket, and in the other bracket it is A1B2 minus A2B1. Now this may look a little bit difficult to remember, but there is a simple way how we can remember it. So let us rewrite the terms of the two equations as a1x square plus b1x plus c1 equal to 0, and the other is a2x square plus b2x plus c2 equal to 0. Here if you look at the first term on the left hand side, which is getting squared, it is c1a2 minus c2a1. So c1a2 is nothing but this particular product, and c2a1. So it is, you can call it as a bigger or the larger cross product. So the left hand side is nothing but the square of the larger cross product. So here let us write down the larger cross product square. By cross product we mean the subtraction of two cross products, that is larger cross product square is equal to, now let's consider this particular expression, that is b1c2 minus b2c1, so which is nothing but this particular, we can say, smaller cross product, and the remaining one is a1b2 minus a2b1, a1b2 minus a2b1. So right hand side seems to be nothing but the product of two smaller crosses. So that's the way we can remember this particular condition. Now this is the condition to have strictly one common root between the two given quadratic equations. Now with that, let's see some of the examples based on these conditions of having one or both the common roots. The first is, find P and Q if equations px square plus 5x plus 2 equal to 0 and 3x square plus 10x plus q equal to 0 have both of the roots common. As we have seen, if both of the roots are common, then the ratio of corresponding coefficients must be same. So therefore we can reason out that p upon 3 must be equal to 5 upon 10, and that must be equal to 2 upon q. So 5 upon 10 is nothing but 1 upon 2. So to get p, we have p upon 3 equal to 1 upon 2, so that leads us to p equal to 3 by 2, and 1 upon 2 is equal to 2 upon q, so therefore q is nothing but 2 into 2, that is 4. So therefore p and q are nothing but 3 by 2 and 4. Let's see another question. Determine the values of k for which the equations 3x square plus 4kx plus 2 equal to 0 and 2x square plus 3x minus 2 equal to 0 may have a common root. So now here we use the condition for single root to be common. Let us write the coefficients, or we can write the equation first. That is 3x square plus 4kx plus 2 equal to 0 and 2x square plus 3x minus 2 equal to 0. Now we know the condition for one common root is the square of bigger cross product, so that is 3 into minus 2, which is nothing but minus 6, minus 2 into 2, so it is minus 4 is equal to, we must have the product of two smaller crosses, so which is nothing but, now let's take the first smaller cross, that is 3 into 3 which is 9 minus 2 into 4 which is 8, and then if you consider the other cross which is 4 into minus 2 which is minus 8k, because we have to consider 4k, so yeah, here also it should be 8k, and therefore the remaining is minus 6. Now therefore on left hand side we have minus 10 square which is equal to 100, that is equal to 9 minus 8k. Now if you take say 2 common, so therefore we will be left out with minus 4k minus 3. So therefore we have 2 cancel with 100, so that leaves us with 50, and if you want to get rid of the minus sign, we can change the sign of this particular bracket, so therefore we can write 50 to be equal to 8k minus 9, and here we will change the sign and make it as 4k plus 3. So therefore now we'll have to expand this particular brackets on right hand side, and we will get a quadratic equation. So that turns out to be 50 equal to 32k square plus 24k minus 36k minus 27 equal to 0. So on simplifying, we get the quadratic equation as 32k square minus 56k minus 77 to be equal to 0. So on factorizing, we will get the two factors as 8k plus 11 into 4k minus 7 equal to 0. So that leads us to the final solution as k must be equal to minus 11 by 8 or must be equal to 7 by 4. So that's the final answer.